Okay, so this is my home automation project. I've been working on this thing for years because, yeah, I kind of lose interest and then I start tinkering again and then I'm busy and then eventually I get back to it. But I've finally finished a version of it that works. And the next step is to box it and actually use it. So the purpose of this video is just to show you the basic components of it. I'm not going to go into too much detail. I will provide code details via a link on Skillshare if you want to watch some of the more detailed technical videos related to the project. And I mean, it's a nice project in so much as I think it uses a lot of little building blocks that you could use for other kind of automation projects. I must just give you some background. I am an engineer by profession or by training, but not by profession. So I'm actually not working as an engineer. So I'm by no means on top of the programming and the electronic side of things. And I'm brand new to Python programming. And the reason I'm giving you this detail is because I think it just kind of illustrates just how easy it is to use Python, to use the Raspberry Pi, and to develop some fairly complex systems, I think, with pretty much zero experience, apart from some training that I did many years ago. So, yeah, I mean, if you do have teenage kids, girls or boys that are interested in computing and electronics, this is definitely the thing to get them because it is so easy to use, and with a little bit of Googling and a little bit of help from numerous Raspberry Pi portals, you can usually hack together whatever it is that you need. As I said, I will be posting up more detailed videos on the project, and this is quite a messy setup. I will be neatening it up and soldering it and putting it in a box and all of that. And we'll film various videos at various stages. But just to give you kind of a basic overview of what the system does. So first of all, the purpose of the system is essentially to measure the ambient temperature. If it is below a temperature threshold which you set via two buttons, push buttons, then it activates a heater. And if it's above it, obviously doesn't activate the heater. In fact, if it's above it, it turns the heater off. And I mean, it has a very practical application. The application being that, you know, when you go sleep during winter, and maybe it's not as cold at the time when you get into bed, but in the middle of the night after you've kicked yourself open, the temperature drops to a very low temperature and you wake up with a sore throat and you're ill. So what I actually did here is I wanted to develop a system that would measure the temperature, and if it drops below that kind of critical threshold, that it actually turns the heater on automatically. Now, I mean, obviously, you know, you need to take into consideration things like oscillation and all of that. So I don't always activate the heater immediately. I'll kind of do the check, wait a certain period of time, do the check again, wait a certain period of time. Otherwise, what you will find is that you could end up with a situation where you have a system which is oscillating. But we'll get into all of those details in subsequent videos. So just to show you now what the system comprises of, so we have our LCD display. The current temperature at the moment is 20.25 degrees Celsius. The temperature that has been set on here is 19.25 degrees. The temperature is being read via our little digital temperature sensor over here, which doesn't require too much configuration. Two little resistors to build a little voltage divider, and I'll get into exactly what sensor I've used and how to set it up in the software at a later stage. And then the brains of the system is obviously my Raspberry Pi. I'm using a Model 2B here, which obviously isn't the top of the range model. It's obviously connected up to my PC via monitor, or connected to the monitor via HDMI at least, which allows one to program it straight from the actual Raspbian interface. And then I've just got my wireless dongle in there and my dongle for the mouse and the keyboard. So that's obviously just for development purposes, and now that the system is finished, once I box it, I'll remove all of those devices. Then in terms of the switching, I'm going to make sure nothing is getting hot here. See, this is a very sophisticated way of checking that you haven't messed something up. Nothing getting hot, nothing about to explode. Okay, no, it's all good. So the actual switching mechanism that I'm using is a solid state module. Now, yes, I know this is a bit of a cop-out. I could have gone and looked for my old power electronics textbooks and actually built this device using discrete components. But that's not I'm not really interested in that. That's not really what I'm into. So I've used this device, and the reason I've used it is twofold. The first point being that I'm going to be switching mains with this thing, and I wanted something that was packaged properly, and that I didn't have to build myself. But then the other point is also that invariably with these types of projects, you build the thing, you use it for a month or two, and then you get bored and you want to reuse the parts. So I thought I'd just invest in one of these SSRs. And I can tell you this thing it's not cheap. I think it costed about, in South African rands, about 340 rands. But if you're going to use it for ongoing prototyping, it's perhaps worth investing in. Obviously, if you really do decide to build the project and you want to scale the production of the project, then you can use cheaper devices and perhaps build it up discreetly. And I suppose the same thing goes for the Pi. So at the moment I'm using a rather sophisticated Raspberry Pi for something which you could have done with a PIC 16 F84, for instance. So I think the next stage in the development of this, I'm kind of focusing on a lot of different home automation areas. The next phase would probably be to build this with a cheaper kind of processing device. Alternatively, just using a Pi Zero as the main unit. But at the moment, we've used the Raspberry Pi 2B. And just to give you a quick demo to show you that the thing is working, so the current temperature 20.75 degrees. Apparently, we are experiencing the worst storm in like 30 years here in Cape Town, South Africa. Doesn't seem to be that bad, but officially that's what they're saying. So let's adjust the temperature. So I'm going to use one of these push buttons over here. I'm not quite sure if this is the up or the down one, but let's just see. Oops. I think that is the... Yeah, that's going down. Okay, we actually want to move it up. So let's use the other push button. And yes, it's a little bit messy. I know, we'll neaten that up. So let's take the temperature up to, let's see, 19.5, 20. Okay. Right. So the preset temperature now is 21.0 degrees. The current temperature is below that. So in other words, my heater should be on. And you can see there's like a little red LED there that is now activated, right? And what I'm going to do while I have that in the focus, in the picture, I'm actually going to reduce the threshold. 20.75, 20.5, okay. So there you will see that it's actually gone off. And the reason it's gone off is because the current temperature is 20.68 and the threshold temperature is 20.5 because I've reduced it. And let's just do it one more time in case you think that I am fibbing you. So you can see that the LED is off, right? Current temperature 20.62, the threshold temperature is 20.5, and if I now say I want it at 21.5, with any luck it should be activated, and it is. So yeah, that's kind of just a demonstration of the project. Now, I mean, obviously I haven't connected any AC device to the secondary side of the solid state relay. But as we progress with the videos and as I give more explanation, we'll do just that. And yeah, so that's the end of the introductory video. I hope you enjoyed it, and I'll be providing Skillshare links if you guys want to get more detail, more technical detail on how the system works, and I'm more than happy to give you guys the code as well. Thanks for watching. I'm Ian Brink, and this is my home automation project.